This is an important concept. Internal field in liquids and solids. First is you take what is internal field. That is important definition. First you take internal field definition, then move on expression for internal field in case of liquid and solid, that is in one dimensional explanation. What is internal field? Internal field is when a dielectric material, you know dielectric material, that is a non-conducting material, either solid or liquid, on the material when the electric field is applied, each of the atoms develop a dipole moment. Okay, ಒಂದು dielectric material ನ ತಗೊಂಡ್ರೆ either solid or liquid, on the material external electric field is applied, so each of the atoms develop a dipole moment. ಪ್ರತಿಯೊಂದು ಆಟಮು dipole moment ನ ಡೆವಲಪ್ ಮಾಡುತ್ತೆ and then acts as electric dipole, that is acts as electric dipole. Hence the resultant field at any given atom will be the applied electric field and the electric field due to the surrounding dipoles. This resultant local field is called the internal field. Okay, so it's called internal field. So simply we have says what is internal field, that internal is the local, or it can also be called as local field, is the electric field that act at the site of any given atom of a solid or a liquid dielectric subjected to an external electric field and is the resultant of the applied electric field and the field due to all the surrounding dipoles. That is called as an internal field. Okay, next is expression for internal field. This expression derivation is not necessary, only its take explanation. That is, consider dielectric material. These are dielectric material, either solid or liquid, kept in an external electric field. Okay, so when the external electric field is applied to the dielectric material, on the strength of the external electric field in the material, let us consider arrangement of equidistant atomic dipoles arranged parallel to the direction of the electric field as shown in the figure. So let us interatomic distance, that is D. D is represents interatomic distance, and electronic polarizability of the dipole is, that is alpha E. Okay, so D is the interatomic distance D and electronic polarizability of the dipole is alpha E. Okay, so that based on the explanation we got expression for the internal field EI is then given as EI is equal to E by 1 minus 1.2 alpha E by pi epsilon naught D power 3. This is expression of the internal field. So next is comes to the Lorentz field. Its Lorentz field, since above equation alpha E and extra electric field and epsilon naught and D are all positive quantities, there is consider EI greater than E. Okay, so now it has been obtained by considered one dimensional arrangement of atom, but in case three dimensional case the general equation for internal field is expressed as EI is equal to E plus nu by epsilon naught into P. This is three dimensional case. Okay, it is one dimensional internal field equation, one dimensional internal field equation. It is three dimensional internal field equation. Okay, where P is polarization and nu is polarizability constant, it is called internal field constant. So in case of three dimensional case, if it is cubic lattice, this cubic lattice concept is appear in crystal structure chapter. Okay, so but in your syllabus crystal structure is not appear. Okay, then it can be shown that nu is equal to 1 by 3, in which event the internal field is called as Lorentz field. In this case only, internal field is called as Lorentz field is equal to E plus P by epsilon naught 3. Okay, so above equation, this equation is known as Lorentz equation. One of the important results that follow from the relative is Clausius-Mosotty relation. Next is we will discuss Clausius-Mosotty equation. There is we can use this relation. Okay, this is one-dimensional equation. This is three-dimensional internal field equation. In case of cubic, three-dimensional case. In case of three-dimensional case, this internal field is called as Lorentz field. Okay, this equation is called as Lorentz relation. Okay, so internal field, what is internal field and what is the expression of the internal field in one-dimensional case and in three-dimensional case. This is important question. Your exam point of view, it's enough.